Welcome. I'm Misko Hevery. I don't know if you guys know me. I'm the crazy guy who does crazy things around here. This is my boss over here who has managed to not to fire me. Hi, Brad. Okay, so we're going to talk about JavaScript. So I've been doing JavaScript for actually for how long? About a year and a half. So I'm pretty new to JavaScript, but I've been doing it very intensely. I've been working on a project called Angular, and I was able to kind of learn how to push the browser into new limits, etc. And so I'm just going to share some of the know-how I have. By the way, this is an introduction in the sense that I want to show you how JavaScript works, not necessarily what the syntax of JavaScript is or all the nuances that I'm sure most of you guys can figure out just fine. So we're going to talk about basic concepts of JavaScript, and mainly the fact that everything in JavaScript is an object, or an object is really just a hash map, right? It's just a hash. And so all the primitive types, which are objects, arrays, strings, numbers, functions, null and undefined, well, null is not really an object, and undefined is not an object either. But all of these guys act as objects. And so what is true of objects is also true of all these other classes. Second thing is JavaScript is a functional language. And as such, there's maybe a little bit of a different way of thinking about the problem than OO. But nevertheless, because we're coming from an OO world, we're going to show you how we can build OO systems, mainly classes, inheritance, and the standard OO conventions that we have. And then we're going to talk about a little bit about the browser. So keep in mind that we're talking about JavaScript in its purest form, not necessarily JavaScript, how it's also tied with the browser and how it's also tied with the API that it has. I'm only talking about the language itself. I personally am a big fan of the language itself. The APIs are kind of interesting, but the browsers is where most people have the hatred towards JavaScript, because all the browsers are different, right? But keep in mind that the differences between the browsers are not the differences between JavaScript, but rather the differences between browsers. And so we'll talk about that in a bit. So if you are on your computer and you want to follow along, you can, let's see, I cannot do it here, but just about any web page you open and you hit inspect element, a little debugger comes along down here, and then you can click on, if you're in Safari or Chrome, you can click on over here and you can type commands over here. So you can say, I don't know, 1 + 2. And it evaluates immediately. So as we go along, I encourage you to go and try these things on your browser as well. Okay, so let's start with the basic, which is we have an object. And so you can really declare objects in one of two ways. You can say new object, and if you're coming from a Java world, how many people are coming from Java world? About everybody, right? Okay, so this should be very natural to you to do. The second one is kind of a shorthand notation, which is just two curlies. How many people know JSON? Okay, so the two curlies should be, again, familiar to you, right? And so this is basically how you instantiate an object. Now, a couple of things that you might not know about JavaScript. First of all, there's this type of operator when you can say, and it actually returns a string. So if you say type of object1, you'll get a string that says object. And you can also say object1 instance of object. Now, here's something interesting. Notice that in the first case, it's returning a string with lowercase o. In the second case, this is actually a variable, which is a global variable called object that refers to a constructor. And so what you're saying there is that was object1 constructed using the constructor function object? And again, the answer is true. And you can try this on your debugger, and you'll see the same thing happens. And all objects have several special properties that are just always present. And one of these properties is, for example, a constructor. And that points to the function which constructed the object. So if you say object.constructor, you'll get back a function that was the constructor. So in essence, the line that says object1 instance of object and the object1.constructor are basically the same way of asking the same question. Well, sort of. In this case, it's the same thing. In a case where you would have inheritance and you would basically have something else like a vehicle that inherits from object, the vehicle.constructor would point to a vehicle, but if you say is a vehicle instance of object, it would still say true. So the instance of operator is a little more intelligent. Not only does it say, was it constructed, it also says, well, maybe some of the parent classes could have been the constructor of it as well. So it kind of works just like you would expect it in Java. Does that make sense? By the way, stop me as I'm talking about this thing. I love questions. If something's not clear, you want more explanations, just go ahead. Yes, go for it.
You said that everything is an object in JavaScript, so isn't instance of object or type of anything equals object?
No, if you say type of, for example, 3, it will come back as a number.
Other than primitives.
If you say type of strings are kind of weird. They're kind of an object and kind of a primitive, and they'll auto-convert on you automatically sometimes. So they'll come back as a string. But in general, for all the objects all the classes that you declared, when you say type of, it will always come back as an object that's correct. But if you say instance of, you might be able to get more mileage out of it. That's a very good point. And one thing I didn't mention is there are concepts of primitive types in JavaScript, and the primitive types are number and Boolean, and I think that's it. String is kind of a weird one. It's a primitive type, but it sometimes behaves as an object. Okay, so on the bottom we just have a simple assignment, and I'm just trying to point out that you can assign in one of two ways. You can either do a literal assignment using the dot, or you can say using the bracket notation and then a string. And the reason why you want to use the bracket notation is that what's inside of it could be a variable, right? So you could have a variable x equals name, and then you can say object1 bracket x, right? And x evaluates to name, and therefore you're saying object.name. Yes?
When I look at this object1 instance object, I just feel like rubbing my hair. Is there a better way to do this, even though this might be legal?
What is it that you're having trouble with?
Like,
can you repeat the question for remote site?
Oh, sorry. He says he's trying to rip his hair off when he sees object1 instance of object.
in other words, is there a dot thing, or you pass this in parentheses or something like that?
No, there is no other notation. I mean, you can create your own function that does this, right? But I mean, if you look at other languages like Java, they have the same exact thing. Like in Java, you would say x instance of class, and it will value to either true or false. So this is something that other other languages have as well. So it's not unique to JavaScript. Okay, so let's talk about the prototype chains. This is kind of where it gets interesting and where all the power of JavaScript comes from. So I can declare a class, I can declare an object instance called vehicle, and I'm going to give it a attribute called powered equals true. And notice before I would just use double curlies to declare an object. It's also possible that I can, inside of those double curlies, enter new attributes of this object. So vehicle will automatically have a property called powered and will be set to true. And I can also create a Volvo, and I'll say that it seats 4. So now I have two classes, vehicle and Volvo, and as you can see, they're completely independent. They're not related in any way, right? There's no references from one to the other. And so if I say Volvo.seats, I will get 4, and if I say Volvo.powered, I will get undefined. And that makes sense because I haven't defined the powered on Volvo. Now what I can do next is something interesting. I can say Volvo.__Proto__. It's a special property, another one of those magic properties. And I can send it to vehicle. What it is basically is if you think of an object as a hash map, what you're setting there is the parent hash map, saying that if I'm going to look up a property called powered, let's say, and if you don't have it set in your hash map, ask your parent. Maybe he has it. And this can be chained as deep as you want, maybe, and so on and so forth, right? So now, after we set the property, I can say Volvo.powered, and it will answer back as true, because while the Volvo doesn't have the powered property, the vehicle, which the Volvo inherits from, does. And so now you get back true. So now I can do something more interesting, and that is I can say Volvo.powered equals gasoline. And so I'm overriding the property powered on Volvo. And so now the question becomes, which property am I overriding? Is it the property on Volvo? Is it the property on vehicle? And the answer to that is it's on the Volvo itself. So what you're doing is you're covering up the property of the parent object. So Volvo.powered returns gasoline, but vehicle.powered still returns true. That was the original setting that we have over there. And we can also say Volvo.proto.powered, and that comes back as true because you're saying go to the parent object, which is now vehicle, and look at the powered, and that becomes true. The concept of type is kind of a stretch. Sorry, to repeat the question. Does it matter that they're not of the same type? Well, there is really no, well, there are types, but they're very vague inside of JavaScript, right? And so there are no constraints, and you can really do anything you want, and the interpreter would be perfectly happy to do this. So there are no restrictions on types in JavaScript. It's a very weakly typed language. Okay, does that make sense? All right, so let's go make some more interesting stuff with functions. So just like you can declare objects, you can declare functions, and keep in mind that what is true of objects is also true of functions, because function is an object. So we can declare a function, and there's really two ways to declare a function. So the first case is what's known as the named function. So you say function add, it takes two parameters, a comma b, and it will return simply the sum of a and b. And I'm also going to declare I can also have an anonymous function, which is the second line, which says function a returns negative of a, and I'm going to assign it to a variable negate. So in the first case, I have a function that has a name add. In the second case, I have a variable negate, which is pointing to a anonymous function. Turns out that there's really very few differences, if any, between these two. The only difference is that if you say add.name, it will actually give you the name of the function. Whereas if you say negate.name, it will say, I don't have a name. It will just have an empty string. But other than that, in both cases, the function pointer, which is where the property negate and add is set to the current scope. Now in the case over here, it's actually going to be on a window. We'll talk about that later on. So if you say window.add, you will get a reference to the add function. If you say window.negate, you will get a reference to the negate function. Anyway, so functions, after you declare them, they can be called. So you can say add 1, 2 in parentheses, and that will call the function and will evaluate it. Not only can you call them in that particular way, you can also call them using apply and call. And apply is basically a kind of a reflective way of calling the function, and we'll talk about that a little bit in a second. So that it takes the first argument, which is the function's this. We'll talk about it in the next slide, so I'll just pass in a null for a second. And in the apply, you can pass in an array of arguments into the function. And so again, if you say add.apply and you say array of 1, 2, it's the same thing as calling the add function directly, and you get 3. The call is the same exact thing, except the arguments are not in an array. So you would say, well, why would I want to do that? You would want to do it because if you want to call a function reflectively and you don't know how many arguments it has ahead of time, passing in an array of arguments allows you to build up any argument strings you want. Okay, so going on, type of add returns a function, just how we would expect. Add.name returns add because that's the name of the function. Because you could say x equals add, right? And then you could say x.name and it will still return add. Does that make sense? Okay. So add.length will return number of arguments that the function has. We already said that negate is anonymous. It doesn't have a name. And I'm just pointing out that type of add.apply is also a function. So not only are you declaring function, each function also gets these two special helper functions, the apply and call, for calling it. And I also want to point out that it also has this special constructor property, which points to a global constructor function called function. And because it points to a global constructor function, that also means you can call the constructor using the new operator. So if I say new function, and I pass in an argument a, and in the second argument I'll pass in a string, which is actually a piece of JavaScript code, this will actually instantiate a new function. It's a kind of a convoluted way of doing it, but this is actually perfectly valid as well. So if you wanted to create functions on a fly, you can do that as well. So does that make sense with functions? Any questions on it? Okay, sounds like we're doing good. Okay, now one more thing about functions that I have to talk about is closures. And this is kind of something that is very new to JavaScript. I'm sorry, it's a concept that's new if you're coming to JavaScript. It's not a concept you're going to have in, let's say, Java. And closures is what's really powerful about JavaScript, but it takes a really while to get used to it and kind of knowing how to get the most out of them. But anyway, so here's an example called greeter. So there's a function called greeter, and it will take a salutation. So let's say the salutation is the word hello, right? So internally, we declare a variable called counter, and we declare a variable called prefix. And a prefix is simply a period plus salutation plus an extra space on the end. And what we are going to return out of this function is another function. It's kind of getting confusing a little bit, isn't it? A function that returns a function. But bear with me for a second. So the inner function gets returned, and so what we can do on the bottom, as you can see over there, is we can say var greet is equal to greeter hello. So the greet variable now is a function that we can call, and that's actually the function that's inside of the outer function. So now if I say greet world, it will say 1.hello world, and if I call the greet world again, it will say 2.hello world. Now why is that? If you look at the inner function, it increments a counter. That means that the state of variables is preserved between invocations, right? That's why the counter keeps incrementing. If you, first of all, if you were trying to do this, something like this in Java, the compiler would force you to declare counter as a final. You guys familiar with what I'm saying? Okay, some of you are shaking your heads. Okay, will force you to declare a final. That's because the compiler actually makes a copy of that variable. It's not really a same reference as it is in JavaScript, but in JavaScript it's actually a same reference. So the function that gets returned out from within the greeter has a reference to a counter, but that's the same reference that when you instantiate, when you called the greeter function that you had, and so that reference persists for the duration, not just of the function call, but also for subsequent durations, because there's a reference to it, and the reference is the function that you returned. So you can think of it as there is a state that exists outside of the function when the function was declared, right? And that state is our counter. Not only is the state the counter, but also the prefix variable is the state. Now, the prefix doesn't change over time as you invoke it, but it also stays. And so the bottom function, the greeter function, the one that gets returned, allows you to basically say hello world or hello, your name over there or something like that. So what we say is that the inner function is bound through the closure to counter and to prefix. Does that kind of make sense?
Say that sentence again.
The inner greeter function is actually unnamed function, right? The inner unnamed function is bound to counter and prefix, and we call the variables that we are bound to closure. Did I say it wrong the first time?
No, it just
Didn't make sense. Yes.
Couple questions. If you created if you invoke the greeter again, the new function that it returns will have a separate binding, right?
Correct. So the question is, if I invoke the greeter again, it would have a separate binding. That's true. And not only would it have a separate binding, but the function returned from greeter would not be the same function as the first invocation. So if you did equal on it, it will return false.
Second of all, does it have a reference to everything in its scope, even if it doesn't directly reference it? Or
that is up to the interpreter.
Repeat the question.
Sorry, the question was, does the inner function have access to everything, even if it doesn't reference it? And that's actually up to the interpreter to implement. I believe the answer is yes, because the closures are really just hash maps and they're chained. And I believe if you're inside of like Firefox, you can Firebug, you can actually see them, but I could be wrong on this. I could be very, very wrong, so don't quote me on it. Because you don't actually have a reference, there is the interpreter could optimize it away and you would never know. because there's really no way to get a hold of the closure object to be able to do reflection on it. All right, somebody else had a question, or was that already answered? So same question. All right, good. So let's go on. Okay, so now that we talked about functions and objects, let's see if we can create a class. And this is something that a lot of people have trouble with, because if you come from a different language, like for example Java, there's only one way to create a class, right? There's the class keyword, and you instantiate a class, and there's specific syntax for it, and the class is a first-class citizen for the compiler, and that's how it is done. In JavaScript, JavaScript is more of a functional language than an OO language, and so there really is no keywords or anything that basically allows you to create a class. Rather, everything is done through conventions, right? So the concept of a class and something that behaves like a class, you can build it in JavaScript, but it's convention only based, which means if you go to project A versus project B, people might have chosen different ways of using the conventions. Now, it sounds like a scary proposition, but it turns out that all the conventions are internally compatible with each other. So if you're passing classes around, you can happily pass it to somebody else, and it works just like you would expect. And they all have different advantages and disadvantages, which is nice to take advantage of, or use it to play to the strength and weaknesses of them. And so it's really up to you how to use it. So let's say we wanted to create a standard example, which is the circle, right? So I'm going to say, let's create a circle, which is an object, and I'm going to give it a property called the radius, which is, let's say, 5, and then I'm going to assign a method area to it, which is simply a function that says this.radius times this.radius, right? That's the power of 2, and times pi, right? Standard implementation, like nothing surprising there. And notice what you can do is that you can simply just assign functions into properties, and they just automatically become so. So you can say circle.area, and it will compute the answer, which is 78 and some change. And really, when we're talking about OO, what we care about is the final syntax of how the user would use the class, right? And so the standard issue is that you have an object, and an object has methods, and you can invoke methods on that object. Like, that's really what OO is at the heart of it. And it also means that the data and the methods travel together. So let's have some fun with this class, just to kind of point out how different the JavaScript is. So let's see if we can decompose the code. So I can have a variable called fn, and I can say fn equals circle.area. Notice, because I didn't put parentheses on the end, I'm not calling the function, I'm simply getting a reference to the function, right? And if I call fn.call, I will get back a nan, not a number. Now, why is that? Anybody try to guess? Go ahead.
This is undefined.
That's correct. That's because this is undefined. What happens is, and this is kind of interesting, is that when I say circle.area, whatever is on the left-hand side of the dot from the function, in this case it's a circle, becomes the function's this. Does that make sense, what I just said? Okay. So when I call the area function, it so happens that that was referenced from a circle object. And that circle object becomes the this of the function. And so when the function body gets executed, this.radius actually points to the circle, and so circle.radius returns properly 5. But when you call the function without the dot notation, you no longer have this. And so if you just say fn and just put parentheses on it, or if you say fn.call and put parentheses on it, it just blows up. Now, it doesn't just blow up, and this is one of those horrible things in JavaScript that I wish they hadn't done. But it's not that this becomes undefined. It's a lot worse than that. If this was undefined, then we would at least have some useful exceptions being thrown. But no, this is one of the grand mistakes of JavaScript. And that is, this becomes the global object. And the global object happens to be the window. So if I do window.radius equals 1, and I do the fn call again, I will get back 3.1415, because 1 times 1 is 1 times pi is pi, right? So this is absolutely horrible. This will bite you in so many different ways when you forget to properly, this is called binding. If you forget to properly bind, and you automatically default to a window, you'll get to these strange situations where, oh, if you have a single instance of an object, it happens to work because you're sharing the global space. But if you have multiple instances, all of a sudden weird things start to happen. And it all comes down to this. And this is one of those horrible things that I wish they haven't done. This is a big gotcha, basically. But it turns out this is where the call comes into play. And now notice I can say fn call, and I can pass in a circle. And what I'm saying now is execute the function fn, which was circle.area, right? But call it such that this is the object circle. And now things work as you would expect. Yes?
Isn't it sort of just the case that all functions basically take variable number of arguments? You know, slides ago you showed
yes.
Instantiated function, and it creates this method called call and apply, and it takes the first parameter is this, and the rest are just the parameters of the function. So, I mean, it looks like what you did was you just called it with a different number of arguments so that it had an argument for that function.
Okay, so
variable. Is that what happened?
sort of. So are you familiar with Python? I'm going to rephrase the question. Okay. So the question was, isn't that each function has a hidden first argument, which is basically the function's this or self. In Python, this is actually explicit. You actually have to say self or this. And the answer to that is not really. And let me show you why. In this particular case, which is we've basically called add.apply, and I explicitly passed in null. I said call this function with null as this. No, JavaScript actually calls it with window. So even if you pass in null or undefined or whatever other thing that doesn't actually evaluate into object, it will still call it with window. So, like in this case, if I call fn call and there's nothing in the arguments, all arguments that are not bound automatically become undefined. So you would expect that you would have an undefined for this. That's not the case. You'll still have window. This is one of those horrible things that's done in JavaScript. As a matter of fact, you can make an assumption that if the function was called without proper binding, it will be a window. And that's a very safe assumption to make.
Do any of the other arguments default as well?
Everything defaults to undefined. Yes. Except for the first argument and except inside of the special call and apply, which defaults to window. Okay. All right. So now let's build up. So this is a primitive kind of a class, and you don't want to really build classes this way because every time you make a class, you basically have to assign all of the methods to it, right? But we know that if you have a class, really there's two pieces to it. There's the state, and there are the methods, right? And we also know that objects can be chained together to kind of have certain properties come from other objects. So wouldn't it be nice if we could simply create a single object that has all the methods on it, and then we would instantiate new objects for the instances, and then we would tie those instances proto to the parent object, which happens to have the methods, and that way we have a nice all going on, right? Does that make sense what I just said? Okay, so as a convention, we put a capital C for a class. So here, just another object called circle with a capital C, and I'm going to put a method on it called area, just like I had before. And on the bottom, I'm going to say var instance, and I'm going to create a new instance radius 5. And I'm going to say instance proto, and I'm going to point it to the circle class. And now I can say instance.area. And the reason this works is because when the interpreter tries to look up the area, it looks into the instance first and says, I don't have it. So it looks at the instance proto, which is a circle. It finds it. Now it tries to call it, and it looks at the the left-hand side of the dot notation and says, oh, I see an instance over there. That becomes the this of the function. And then the function executes as it normally would. Does that make total sense? All right. So this is a kind of a standard way of the way many languages do this, is that they have the concept of a class and they have a concept of an instance, right? And if you're in Java, the class is actually an object as well, and so is the instance. So it kind of gets convoluted a little bit because everything is an object, but really there's a different thing if it's an instance and a different thing if it's a class. What you can do is actually, if you declare a property on a circle with a capital C, that's essentially the same thing as in Java declaring a static property on a class, right? Because that's shared across everybody. The only difference is that, well, no, that's the same thing as in Java. If I declare a property, if I declare a constant name equals Google, let's say, and I say private static, that's the same. Within the code, I can simply just refer to Google and it will automatically be available. And so it's the same thing here. If you say circle.google, it would become automatically available to you because you just automatically have it inherited to you. Does that make sense? Okay. So we can achieve the separation of a class from the instance using this trick. The only problem is with this so far is the notation, right? Notation is kind of a pain that I have to set the proto and there's really no constructor and all this stuff. So let's see if we can solve all these problems one at a time. First, let's see if we can do a constructor. So let's say we have a function called circle. And again, this function is in no way special. It's only a convention, right? And so it's not like a special function like in Java that the constructors are really special functions and you can't call them on. No, it's just a function. And as a notation, we're going to put a capital C from Java. I mean, I come from the Java world, so I put capital C, meaning that it's a class. To say it's a constructor. And what we're going to do inside of that constructor is we're going to say this.radius is, we're going to set the radius on it, and we're going to say this.area, and I'm going to set the function on it as well. So this constructor will build the object for me automatically. So now I can do something interesting. I can say var instance. I'm creating an empty object, and I can call the constructor by saying circle.call, and I'm going to pass instance as this to the constructor, right? And the second argument is 5, which is the radius. And so that will actually construct, we will assign the radius to the instance, and we'll also assign area to the instance. And then I can say instance.area, and we'll compute the answer. But there is a shorter way of doing this, and that is to simply say new circle 5. The first two lines are almost, with few little differences, identical. So any function in JavaScript can be a constructor, and the new keyword is just a shorthand to saying make a new object and call the constructor as this parameter on that object. The new keyword has no other meaning. So let's see how they're different. Well, I can call an instance2, both instance and instance2, I can call the area and it will result with the same answer. But if I say instance of circle, I'll get a false. Whereas if I say instance2, instance of circle, I'll get a true. The reason why we have this difference is because, remember I said there is a special property called the constructor? In the new operator not only instantiates an object and calls it, but it also sets the constructor property to itself, so that if you say instance2.constructor, it will point to this circle function. Whereas in our case, we didn't do that, right? And so our instance of doesn't really work properly, and so we can fix that. We can, well, I don't have it on this slide, but if you would have said instance.constructor equals circle, then the instance of would properly behave the way you would expect. Okay, so this is a pretty good class. Like, we're getting pretty good in terms of syntax into what we want from a OO system. It's pretty usable, very close to Java. The only feedback I have on this is that we don't have the separation between a class and an instance. Rather, every time we call the constructor, we're constructing a whole bunch of functions. And those can take up space and means you can't really pass them around. It also means because the function is inside of the other function, that function has closure, which means that function has a reference to radius. It could have, right? In our case, it doesn't. But I could have simply dropped this.radius and just say radius, and it would still work the same way. So while this is definitely one way of declaring a class, it has certain side effects that I'm not really fond of. And so let's see if we can build an exact class that behaves just like you would expect it in Java. And so for that, what we really want to do is we want to say function class. We want to instantiate we can instantiate instance 1 of that class, and then we want to compare it with another instance done the different way. So here we instantiate 2 by just creating an object. We're assigning the constructor back to the class on the top, and we assign the instance 2 proto to the class.prototype. Now what is the prototype? Turns out that every function has this property, special property called prototype, and we're going to talk about it in a second. And what the prototype does is it has basically, when you instantiate the new class using the new operator, not only do you set its constructor, you also set its __ proto to the function's prototype, which means you are automatically setting the parent class of that object. Parent in terms of property inheritance. So what I'm trying to show you is that the instance 1 new class is absolutely equivalent to the instance 2 code. If you create objects in these two ways, there is no way you can tell them apart in runtime. So the new operator is equivalent to creating an object, setting the constructor to the class, assigning the proto to the class's prototype, and then calling the constructor on that class. So if I say instance 1 or 2, that weird notation is instance 1 or 2, that constructor will be to class. If I say instance 1 or 2 proto, it will be class.prototype. And if I say instance of class, it will return true. So you cannot tell these two objects apart. They're identical at runtime. Okay, so let's talk about this prototype for a second. This is kind of interesting. So what does the function's prototype do? So again, let's go back to function, and we declare a class called circle, just like before. This time, all we do is assign the property to the radius, and every function automatically has a property called a prototype, which happens to be an object. And so we can assign other methods or anything we want into the prototype. So in our case, we are assigning our area function into it. When we instantiate the circle using the new circle 5, right, the new operator sets the instance.proto __ to the circle.prototype, which means it automatically inherits all of the methods that it had. And so this is the kind of the classical way of defining a class in JavaScript, because it provides the separation between instance data and the functions. The functions are declared in a higher level object, which gets its properties automatically inherited. Does that make sense? Or did I confuse myself? No questions? All right, good. That's usually one of those things that's hard to grok, but I'm glad that. Yes?
What's the difference between the __ proto and the prototype?
Okay, what's the difference between prototype and __ proto? Good question. The __ proto is what the runtime uses to look at the parent object in order to resolve a property. The .prototype is a special property name on a function, and on a function only, which is what the new operator uses to copy onto the __ proto __. You can think of the prototype as a template, and the proto as the runtime reference to the parent. Confused, huh? Sorry, I'm not explaining it right.
In practice, do people tend to use __ proto?
No, it's hidden from you. So it turns out, good question. In practice, do people use the __ proto? Sort of. It turns out you can read __ proto on all browsers, but you can only write to it on everywhere but IE. So many of the examples I have showed you will not work on IE, but that's okay because you can always do it through the new operator. So why is it a little confusing is because circle.prototype is an object, which means circle.prototype __ proto could have other object hanging as a parent of itself, which is how you would do inheritance in JavaScript, but I'm not going to go there because that's even more brain twisting. So every object has __ proto, but only functions have prototype, which is the template used for creating a new operator. Hopefully that kind of helps a little bit. All right. Okay, so let's talk about the function binding problem, which is that we have our this disappear on us from time to time. And this is something that's really useful to have. So because functions are first-class properties, which means you can just pass them around, call them, etc., it makes for a very different kind of style of programming. In Java, if you wanted to do a callback, you have to have an interface, the interface has to be implemented, and so 50 lines of code later, you finally have yourself a callback. In JavaScript, you can just pass a function somewhere and you're done. So let's look at this example over here. So let's see, we have a class called greeter, and there's a method called greet on that class, right? And the greet takes a name. And suppose there's another class called server. So I'm instantiating greet, and I'm also instantiating a class called server. I haven't declared server in this example because I've kind of ran out of space. But just imagine there's a server class somewhere, and the server class has a method called getUser. And here is something interesting in JavaScript, which we'll talk about in a second later, and that is JavaScript has exactly one thread, and that thread is responsible not just for running your code, but also for updating the UI for the page. Which means that if you wouldn't be a disciplined JavaScript programmer and you decided to do something like server.getUser, and server would take 3 seconds to come back with a response, your UI would be blocked for 3 seconds. We don't want that to happen. So it turns out that every single API call in JavaScript, or rather in the browser, right? Because now we're leaving the domain of the language and now we're in the domain of the APIs. All APIs in the browser are non-blocking, which means it is every method call that you call instantaneously returns. I mean, there's some intrinsic time that it takes to execute a method, right? But they all return immediately. What that means is that it is impossible to write a piece of code that doesn't return essentially from a user's point of view immediately. Now, it is possible to get yourself in an infinite loop, right? But short of getting yourself in an infinite loop, you're always going to have to be forced to return immediately. So now, if you have a server object that talks to an external resource like a server, and that takes several seconds to come back with a result, how in the world do you process the result? The way it's done in JavaScript is that you call the method and you pass in a function that will become the callback. What it means is that here is a function that I want you to call when you are ready with your data. Right? This is very different from Java programming, where you simply say, call the, in Java you would say, var name equals server.getUser, and that call would block for several seconds until the server would come back with a response, and then you would continue your execution. So everything in the Java world, JavaScript world is non-blocking. So you have to pass in a function. So what we want over here is to simply say, look, once the server comes back with a result, why don't you just greet the user using the greet method, right? But do you see a problem with this? The problem is that you pass in the greet function, and that greet function, when it gets called, will no longer have the proper this associated with it. So when the function says this.salutation, it will get the window.salutation. Right? And that's a problem. So what we need to do is we need to do the second form on the bottom. It says server.getUser, and we're passing in a function that has a name, and that function simply forwards the call onto the greeter.greetName. And because the call is being forwarded, now the greet method has a proper this, because the greeter variable is enclosed, right? It's the part of the closure of the function. And so this is basically what's called binding this to a function. Does that make sense? Why that's necessary? Okay. So now this is necessary, and this is basically how you solve this problem. But it's a kind of a pain in the butt to do, because you have to do it everywhere whenever callbacks are involved. So let's see if we can do something to help out with this. Let's say we declare a function called bind. And that function will take the function's this and it will also take a function. And it will return a new function, and when you call that function, it will forward on to the fn function, and it will call it with the functions this method. And oh, by the way, there is this hidden property called arguments, that is the arguments of the function that happen to be called, that you happen to call. And so we're just going to forward on all the arguments that you called with the function onto the next one. It's a little mind-bending here, but do you see what it's doing? You're saying, give me a function such that if I call this function with the improper this, you will call it, you will forward the call on with the proper this. So then what you can do is you can simply say server.getUser, and you say bind the greeter to greeter.greet. And that will do all the magic for you, so you don't have to do all the pieces. Okay, I think this is all pretty much what you have to know about JavaScript. So now we're going to go and talk a little bit about the browser.
I have a question.
Yes?
So if you can go back to the last slide. You said that when you call a function, the left side of the period is the this.
Correct.
So if you call it greeter.greet, why is it this, not the greeter?
Because you're not calling it there. Sorry, the question was, thank you, Brad. The question was, the left-hand side of the function, on the left-hand side of the dot becomes the function's this. So why is this necessary? It's necessary because the greeter.greet on this page, you are simply getting a reference to the function. You're not actually calling it. There's no parentheses over there. And when that happens, when you don't call it immediately, you are losing the left-hand side of the this.
When you actually call it, you don't have greeter.
So when you call it later on, all you have is a reference to a function, and you no longer have the context, which is the this, which belongs to that function. That's a good question. Yes?
This apply, was it really necessary, or could you have just written fn this dot fn argument?
It's actually necessary. So the question was apply necessary? How would you call fn this dot, and then you have to call the name of the function. You don't know the name.
fn.
So you would say what, fn
Yeah.
this dot fn?
Yeah.
Well, but so okay. That requires us to go all the way to the beginning. So what you're saying on the bottom of there, you see object1.name. The name is the name of the property. So now you're saying, if you say fn this.fn, you're saying take the property fn of the fn this, which is not the same thing, right? Right? What you want to say is you want to say fn this bracket fn name, but then when you do that, again, you lose the this because you're no longer using the proper notation. So unfortunately, apply is necessary. Oh yes, so I wanted to actually point out one more crazy thing you can do in JavaScript, and that is because all classes that are built in, which is the object, string, array, and so on, are built in, they have the proper constructors, everything. You can actually extend them. So here's an example. Let's say I have a text, and the text is hello. And I'm going to say type of text is it's string. So therefore, text.proto should be string.prototype. And it actually is. It returns true. So then I'm going to say text reverse, and that's going to say, well, I don't know what reverse is. Okay, no problem. So I'm going to say string.prototype.reverse equals function. And I'm going to declare a reverse function inside of there. And inside of that function, this is the string that I'm interested in. And that means that later on I can say text.reverse equals, returns back hello in reverse notation. The thing I'm trying to point out here is that you can extend the internal behavior of classes, and you can also override it. Is this a good idea? Probably not, because if you decide to write a reverse function and then you use somebody else's library and they also decide to use a reverse function, you could have collisions. There's a library over there called Prototype, I think. There's a JavaScript library called Prototype, not to be confused with the prototype of a function, where they've chosen to extend the prototypes of existing JavaScript classes. And that library is essentially became the incompatible library with everything else. And so because of that, they were the first ones, so luckily they end up having to own these classes. everybody else goes out of their way to make sure they don't touch the built-in types, because just in case you have a prototype.javascript included, it will break whatever you have. So not a good idea. If you are writing a library, horrible idea. If you're writing an end user application where you have a full control of all the classes that are in there, this is probably okay to do. So depending on what you're writing, it might or might not be a good idea. I just want to point out basically that you can extend types as well. Okay, we're running out of time. Iteration. You can have an array. Array is declared using the square bracket instead of the curly bracket. And if you think about what an array is, it's essentially an object that has a special property called length, and it has keys, which is 0 is car, 1 is book, 2 is table. So the next line makes total sense if you think about it in terms of objects, because you just say, oh, well, iterate from I equals 0 until I is less than the special property length. And then when I want to reference the specific key, I simply say log, I'm sorry, that should say array of I, right? I'm concatenating an array. And so the result is that you're going to have car, book, and table concatenated together. But you can also do something else. There's another way of doing iteration, and that is you can iterate over the keys of the object. And that is the second for loop, which is you say for I in array, and that basically returns 0, 1, 2, 3, or if it's an object, it will return the keys of the object. So in this second case, you're actually returning 0, 1, 2, and if it's an object, will return name, greeting, blah, 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 and so on and so forth. So actually, I believe we have an example over here, which is that if you have an object called Spanish and you iterate over with the for key in Spanish, the key becomes the left-hand side of the pair, right? The house and the hello, and the Spanish of key becomes the right-hand side, which is the casa and hello, hola. Okay, I'm going to fly through this because, right. So now let's talk about browsers a bit. So yes.
So I guess one thing worthwhile mentioning is that you have hidden properties on these objects that you don't get with the enumeration.
Correct. There are hidden properties all over JavaScript, and I should have pointed that out. And there's actually another hidden property called, which is a function called hasOwnProperty, which you can call to test to see if the property you happen to get is real or hidden. More advanced stuff. Okay, so there's this global object called window, which we talked about earlier, and everything defaults to window. It turns out that if you declare a function greet, just like this, it's always declared inside of some scope. And if it's really declared as it is over here without a scope, it becomes the window. So function greet can be called directly as greet, or it can be called as window.greet. But notice that if inside of the function I create a bar salutation, the window.salutation obviously is not it, because that's specific to the function. But if I forget to put the word var in front of it, like I said message, and I was really wanting to say var equals message, you automatically get the window.message set. So again, it's one of those horrible things that if you forget the keyword var, the variable becomes global. It's the most horrible thing ever, but you got to live with it. So don't forget the var, because the code will kind of work as long as you have a single instance of something. And if you have two instances, then obviously the state will clobber each other. So anyways, I'm just kind of pointing out how the var works and how the things are always declared inside of the scope. Okay, we talked about the asynchronous API a little bit. And I want to, XHR is the typical thing we use called the XML HTTP request, I believe. And so let's say you want to make a request called a GET request to a server on some URL. You have to provide back a function. This is the callback function that gets called at a later point in time. We kind of talked about it already. But what I want to point out is the pseudocode of how the browser actually works behind the scenes. Again, remember there's only a single thread executing everything. The nice thing about it is you don't have to worry about locks, you don't have to worry about somebody else concurrently modifying something. Like, you are in control when you're in control, and there's nobody else doing anything else. The way it works inside of the browser is that there's a queue of things to do. And that queue is usually ordered by time. So every thing to do has a timestamp when in the future it has to be done. That way you can do things like animation, when you have to scroll something from left to right and you have to make sure that every 30 milliseconds something happens, there's a special method for inserting stuff into this queue. But if a callback, if the browser makes a request to a server, and at some point later the server comes back with a result, the result gets enqueued on the head of the queue. So it gets automatically inserted. And this wait for event is the only blocking call within the whole browser. What that does is it says, wait until you have something to do. If you have something to do, execute it. And then after you execute it, update the screen. Maybe the DOM has changed as a result of the execution, and if so, go redraw the screen. And this is in a tight loop like this. This is when sometimes when you get into an infinite loop inside of your JavaScript, that's inside of the event portion of it, the browser will say, hey, your JavaScript has been running for 20 seconds. Do you want to kill it? Looks like something bad happened, right? Because you shouldn't really ever have to do something for 20 seconds. That means something is broke, right? Because all the APIs are non-blocking. So I just wanted to kind of point out how kind of the browser works internally. And I'm sorry we're kind of running out of time. I don't mind speaking further. Let's just keep going. Okay, if you have to go somewhere, I apologize for going over time. Okay, so let's talk about the DOM. So now we're kind of leaving the domain of JavaScript and we're going into the domain of how the browsers work. And so when people complain about how horrible JavaScript is, what really they're complaining about how bad the DOM is. Okay, the JavaScript itself is actually a very nice language. It's very consistent across browsers. It's the DOM that will kill you. So what is a DOM? DOM is the parsed representation of the HTML in the standard document object model, which means you can get a node, you can get a children of its node, you can get attributes, and so on and so forth. And it turns out that if you modify that DOM node, the browsers will automatically redraw to update whatever the changes you've made. So let me give you an example of it. So here this piece of code actually executes. So if you can say window.document.body, that gives you the body element of the DOM. And you can say body.innerHTML, and we can do an assignment, bold, hello world in italics and bold. And this will actually set the browser's body tag to that HTML. Then you can do something more interesting. You can say, okay, well, let's grab the person. So person is really just take the body and get me the elements by tag name I. So because there's only one I ask for the first one, right? So it gives me an array of all the I's in the DOM, but really I'm interested in the first one. And I can say person.textContent, Misko, and so now it will say, hello, Misko, right? And this is basically how all of the AJAX applications work. They're modifying the structure of the DOM on the fly. That's the whole magic. Now, thanks to W3C, the DOM API is horrendous to work with. It's just bad. What they try to do is they try to design an API that would work for every single language, everything from C to JavaScript. And as a result, the API is really hard to work with. So there's lots of libraries to kind of make this thing easier, and we'll talk about them maybe a little bit in a second. But I want to go over a couple of JavaScript gotchas, and that is the OO is by convention only. So people, when they come to JavaScript and they see OO in there and they say, what is this crazy language? You can declare a class in 3 different ways. And the answer is, yeah, you can declare in 3 different ways, but that's because it's a functional language, it's not an OO language, and we're just coming at it from the point of view of OO, and we are so desperate to create classes inside of our language that that's just kind of what we get. Everything defaults to global window, so watch out. If you don't have a var, you'll have a window. References to functions lose this, again, default to window. And a browser is single-threaded, and all calls have to return immediately. And it's impossible to wait for something, and we kind of already pointed that out. So browser incompatibilities, this is kind of the stuff that you have to watch out for. So as I said, JavaScript is remarkably consistent across browsers. I have found very few differences between the way JavaScript works between all the browsers. String bracket is one of the things that doesn't work in IE, and it's always IE that's different. Everybody else is fine. Trailing commas, for example, in IE, that's going to be an array of 3 elements with the last element being null, whereas everywhere else it's just an element of 2 elements. In IE, you cannot set the Proto. And then, of course, what's different is all the APIs between the browsers, right? So the way you interact with DOM is different between all the browsers. It's not the fault of the language, it's the fault of the APIs. Now, DOM and CSS, on the other hand, is remarkably inconsistent between browsers. The way you interact with it, what gets rendered when you put the same set of DOM and CSS elements is going to be different. And so, there are all kinds of, so for the DOM problem, there are lots of third-party libraries, including Google's Clojure, that deal with the inconsistencies between the DOM manipulation, and they do a fairly good job of abstracting it away. The CSS inconsistencies, though, there really is no solution, or at least no good solution. So if somebody can come up with some, the world would be very thankful to you. And the engines really are the IE engine, the WebKit engine, the Firefox and Opera engine. Turns out the WebKit, Firefox, and Opera are pretty consistent between them. WebKit is obviously Safari and Chrome together, so they work almost identical. The IE is always the odd one out, and even IE 5, 6, and 7, especially across CSS selectors, is very, very different. Oh yeah, and memory leaks is one more thing that should be noted. So JavaScript objects have a separate memory heap. So for those of you who are from C++ world, you should know what memory heaps are. And the memory heap is managed using a standard issue, advanced, these days are pretty advanced garbage collectors that know how to do mark and sweep, and they can take care of circular references, and it's not a problem at all. DOM, on the other hand, is written in C or C++, because that's what the browser is written in. It has its separate memory heap. It uses malloc and free to allocate stuff, and it has ref counting internally. That's how the browser knows whether it's time to allocate something, is if the reference count goes to 0. But the ref count does not detect circular references, because the ref count never goes to 0, and so you have a memory leak, right? Now, this isn't a problem for you because you're not developing C code for the browser. If you're a browser developer, then you have this headache, but you don't. You're writing JavaScript. But you can cause a memory leak when you create references between those two heaps. So I can create a JS object, and in the JS object, I'm going to have a property called element, and I'm going to point to a document.body. The document.body is actually an element that is a DOM element, and therefore it came from the C++ heap, not from the JavaScript heap. Now I can do the reverse. I can say document.body, my attribute, I'm going to point it now to JS object. And now you have yourself a circular reference between the two heaps. Right? It's not that the C developers made an error. It's not that the JavaScript is inherently flawed. It's that you are now working with two different kinds of heaps in here. And there's a lot of different ways to create a circular reference, not just creating a property. Also, for example, adding a listener or passing a function, because with the function, remember, comes the full closure. So not just the function itself is a reference, but also whatever the function happens to see, that is also a reference. And so that's how you create a circular reference. Now, this is normally a problem, is normally not a problem for normal applications where you go between pages, because as you leave a page, the browser says, well, I'm going to blow away everything, so any ref counting must be 0, and so everything is clean. But for an Ajax application, you never leave the page, and the page is open for long periods of time, and so that's where the memory leaks can happen. Okay, so I'm kind of done, but I'm going to leave you with a couple further reading. John Resing is the first link. He's pretty famous. He's the guy who wrote jQuery. jQuery is a beautiful functional library for manipulating the DOM. Superb if you like to look into it. He has some crazy puzzlers in terms of JavaScript and what they do. Check it out. I personally like the W3C schools reference for looking at both the DOM and JavaScript API. People keep telling me that this JavaScript, The Good Parts, is a really good book. I've never read it, but I don't have a reason to believe that it's not a good book, so I recommend it. And there's a couple of readings on functional programming, which is very, very different than OO-style programming, which is a separate talk in itself. And then JavaScript libraries. So if you want to manipulate the DOM, jQuery and Clojure are two wonderful APIs. The Clojure is very OO-centric, whereas the Clojure is very functional-centric. So it's a different approach to the same problem. There is if you like functional APIs, there's this project called underscore.js, which has all kinds of crazy functional like map reduces, etc. in JavaScript. Very interesting. And I like to think that JavaScript, we always try to put Java in the browser, and I think we actually have it wrong. I think we should put the JavaScript on a server. And so there's this project called Node.js where there's JavaScript on a server, and you have the same exact setup, that you have a single thread that services tens of thousands of connections. And because because all the API are non-blocking, it is impossible for you to block, right? Normal servers, have a single thread for a request, and that thread blocks until you're done with the request. Because of the non-blocking nature of the API, you can have a single thread that can handle tens of thousands of requests concurrently. It's a very interesting system. And it simplifies a lot of things because you don't have to have locks. Locks are just a pain to work with. And then, of course, there's this CoffeeScript, which tries to basically create a new syntax for same ideas as JavaScript, but it tries to have a better syntax for it and tries to fix these craziness like you forget to put a var and it becomes global and you have to bind functions, etc. So it's kind of good places to read to kind of explore different directions. And I think that is it. So thank you.